Homework last night, I was having a little trouble understanding the minimum degree of the polynomial. I wasn't sure if you were asking for two of them or just one of them.
On which one? The 4-2 homework is what you're talking about?
Sorry?
Are you talking about the 4-2 homework or
4-4 homework?
on 4-4 homework? So which one?
The minimum degree of the polynomial.
Okay, so that is the turning point thing. So if we have, I don't know, say 5 turning points, what would the minimum degree be?
4. I'm sorry. Minimum as in.
Oh, actually, this one. Oh, no. Wait. This is not comparing turning points. This is comparing zeros to the degree of the function.
Okay.
So you have to like. So if we have zeros, each one of those is basically a factor, right? Or we have an x in there, sort of.
Mm-hmm.
So let me see if I can bounce over here. These are multiples or have multiplicities of larger than 1 in this problem. And so if I wanted to know what the minimum degree of this polynomial would be, what am I doing there?
Oh, we won because there's only one. It doesn't multiply.
So I'm looking at this thing and I want to know the minimum degree. If we multiplied all these things together, what would be the power on my x? This is another way of kind of asking that.
Multiplied all of them together?
Yeah, I don't want to do that.
Right. So
but if I did these two, it'd be an x squared. If I did these two, it'd be an x cubed in here. And I have an x in here, right?
Right.
So basically what I'm doing is I'm looking at
the exponents.
Yeah. And so I have 5, 6 of them, I believe, right? And so this would be a degree 6.
6. It's asking for the minimum.
Can you just write a polynomial that's not factored, but like just in expanded form, like f of x equals x to the 6th plus 4x to the 3rd minus 2 or something like that? Because sometimes they get confused. So what's the degree? What is the degree there?
18, I guess.
On this one. So if it is, each term is separate, not factored, what we're looking at for the degree of the function is the largest degree.
All right.
So what's your largest degree here?
Oh, 6.
Yeah, so this is the degree 6.
Okay, so really, when we're asking for the minimum on the f of x above, it would just be 1, right? Instead of 2. In terms of exponents, are we supposed to
multiply? Here, if they wanted the minimum degree for this function, so it's like this because it's factored out.
Yes.
But if we started multiplying things together, this would give me what, x squared minus 6x plus 9 or something, right?
Mm-hmm.
And so I would start getting things. I'm just looking at the largest term. I'm going to get an x cubed here and some other junk, right?
Right.
But when I go multiplying these things out, x squared times x to the 3rd times x to the 1st, the largest term, the leading term here would be this one being multiplied out, like 3 plus 2 plus 1. So this would have an x to the 6 would be the leading degree if I multiplied all this thing out. Does that make sense? I can probably.
No, I understand completely. It's the exponents that really determine the degree of the function.
Yes, it's the largest one there. If you write it in descending order, it's going to be the first one, right?
Right.
Yeah, so it's the largest one you got there.
Just going 1 up, 2, and 3. So
I was thinking maybe I could just do it the cheap way.
Second?
I was thinking maybe I could do it the cheap way if it's like you weren't seeing the thing. Doing x plus 2. I could do it like this. See if it does it. Hold on.
Take your
time. Does it show it? Oh, it will. That's crazy. Yeah, I don't want to do that by hand. So I'm going to totally cheat and not do it by hand. I am going to do it by computer. Share screen. And so I was hoping maybe this would get at what I'm putting in, right?
Okay.
If we do like x minus 3 squared and x plus 2 cubed and x minus 7, I could expand that and write it out and multiply it all out. But the expanded form is going to end up looking something like this, right? X to the 6 minus
Yes.
7x to the 5th. I didn't want to do this all by hand,
Thank
definitely.
God.
Come on, Matt.
I know we got a lot of extra time, but that's not
Brand new
this thing to do
exploits.
by hand. And so what's happening is, if you want to know the degree of this function, it's going to be that largest degree, x to the 6. And I know you
Okay.
probably saw it, and I'm probably putting the nail in the coffin on it, so to speak, or whatever.
Well, it's always good to know all the corners.
Yeah, it's good that other people can see it. It's good.
Mm-hmm.
Yeah.
So when you ask for the degree, you're looking for the largest, correct?
Yep.
Okay. One of the questions is asking for the minimum. So really, for the minimum, I would just go to the smallest. And so it'd be like x.
No. They want to know this one. They're talking about the degree of the function. What is the minimum degree? So the thing with that is that we have these zeros here, right? And we have a zero that you probably said it's a multiplicity of 2 or something like that, right?
Right.
Well, in reality, that multiplicity could actually be larger. It could be a 4 or a 6 or an 8.
Uh-huh.
But just for simplicity's sake, we're probably just going to keep them at 2.
Okay, I see what you're saying. It's not so much the
minimum degree in the
power
polynomial.
of the number.
Yeah, it's the minimum degree that the polynomial could be.
I understand now.
Yeah.
So if it's factored, you add the exponents, and if it's not factored, you just pick the biggest one.
Oh, that simplifies it. Okay. I'm going to go ahead and guess that's going to be another question to pop up.
About the zero, I don't know.
About the degrees?
I think they asked that quite a few times in here, if I'm not wrong, but I could be wrong.
Well, it's only on the written homework, but last time.
I saw it on the written part.
Right. Other than that, well, it was pretty straightforward. Really wanted most of this in factored. Or factored form.
So does everyone know how to recognize from the graph whether you've got the multiplicity of whatever the roots are, like a double root or a triple root?
Yeah.
I can understand up to a certain point, but I mean, how complex would these get?
We're not trying to make them overly complicated.
Okay. Yeah, because
if it looks like a squiggly, if it looks like a cube squiggly looking thing, then it's a cube. If it looks like it's a vertex of a parabola sort of thing happening, and it's just like it's hitting the axis
squared
back around. Yeah.
Okay. So they shouldn't get too much more complicated than that then.
But you should understand it could be higher evens and it could be higher odd degrees hiding in there, right, so to speak. So it should be like a consideration, but we're definitely not going to go too deep into that. Okay, so right quick, like a little recap of something that I saw on the homework. And this is just like a little bit of like formatting sort of stuff in vocabulary. It's not a big thing, and I don't think I'm not counting off anything for this. But you were like supposed to graph this function, and so to graph this function, I think we had to find the real zeros of it. And so I don't want to spend too much time. I think most people were getting the real zeros or something like x equals a -1 and x equals 5. And I didn't talk about this at all, so, or we have talked about it. It's just been a few nights. But then they asked something about like the solution set of this thing. And if they're asking about a solution set, this thing should really be a set. And I don't know how much we've talked about it, but it should really be in like set notation. So it should have the little set squiggly brackets. And some people are giving me the intercept. Here they just want the x values. I just want those 5. And so I think someone did put -1.5 in. I know like I didn't count anything off, but technically this is like not the thing that they're asking for. that might mean the interval, or that might mean the point minus 1, 5. I don't know by context. But this would be a span of numbers, right? If we were talking about the interval from -1 to 5, this is just talking about two single numbers. And we did this like way back when we talked about sets and like how to do single sets. It was like way back. So definitely not taking off or something like that. But I like noticed a lot of people like didn't really know the format of it, right? It was mainly the main thing. It's just like, it's a petty little thing, but they're trying to build up to something, and it might be worth kind of noting, like we're building a set here, right, of numbers. This is what our solution could look like. Our solutions in things like this in equalities are going to be like single numbers. When we get to things like inequalities, it could look more like something like that, maybe, right? Who knows? I think we're not even doing inequalities anymore. Okay. All right, so 11's on there. Are we ready to get started on this, or do we have any other questions from anything past? All right. So we got like 12 problems. I threw up like two little things. So 41 and 42, I think or 41 wasn't on there, so I threw up 41, 42. They're pretty much the same, so I think we should probably go through both of them. The other one that's on here that like isn't on your list is 44. So all in all, I think we got like 12 problems to get through. So it should not take us too long, hopefully. I think we will have plenty of time to get through these. These are not like, I don't know. Man, I don't mean to sound dismissive, but I think they're like, can you look at the graph and do you understand the concept sort of thing, right? I don't feel like there's a lot of algebra to be done per se right here. Not a lot of number crunching. It's more like, do you understand the concept? Do you understand the notation? So,
Go ahead.
yeah, go ahead. What did you have a question?
Well, no, sorry. Looking over the homework, and yeah, I've missed 11, but that'd be a quadrilateral with a leading coefficient of 7.
Mhm.
So, like, I knew in the video you were setting up the coefficients outside the factor form, but what do we do with the 7?
All right, so we got a quadratic. It's got a leading coefficient of 7. So this is like telling me what A is 7 or something.
Yeah.
Sometimes we just say A is the leading coefficient. So the other thing that this is giving me is I have a what? Minus f of -3 is equal to 0. What is that telling me?
One of the
Yeah,
X.
The X is what?
Am I cutting someone off? Like I can hear an echo when I talk. I don't know if it's somebody else. I guess not. No, I thought F3 means like it's one of the X's.
Okay, so what is this telling me? Is the X is a -3 that we're saying, or is there something else happening? Or is X a +3? I don't know. That's what I'm asking. Is that giving you the X or the factor? I guess it's a different thing, right?
I think X would be a +3.
Be tricky. What is it saying? It says if I plug in a value of what X is a -3, I'm going to get a 0 out of my Y. So this is giving you the X value. So this is telling me when my X is a -3, I'm going to get a 0 out of that Y. This is telling me the same thing. X equals. So they are not giving me the factor here, they're giving me the X. So if I want to get the factor, what does the factor of this thing look like?
X -3, X + 2. Oh, parentheses, of course. X -3, X + 2.
So if the 0 is a -3, the factor is going to look like what again? How does this differ from this?
It would be a +3.
It should change. So this is x equals k. This should be like x minus. This should be the opposite sign here. Same thing. Okay. So this should be
X minus 2.
x minus 2. And I'm kind of working this backwards from what we've been working it. But if I wanted to, I could find the zeros of this thing, right? If I found the zeros, I could go back and plug in -3. That's going to zero this thing out. Or I could go back and plug in 2, and that's going to zero this thing out. So if I wanted to find the zeros, I could. That's not the question they're asking for, though. What they're asking for is to find this thing, right? So I went on a little bit of a tangent there, maybe. But I want to find my function. But if I wanted to check that these things are true, right? I could go back and plug it in. If I plug in a -3 to my f of x, it's going to make it 0. Okay, so it's pretty much set up there. There's one other thing I need to put in here.
7.
7. And it's the leading coefficient in factored form. If we distribute things, it's also going to be the leading coefficient, right? Does that make sense? I mean, we can do it right quick. Okay. Trying to do math in front of a class. So that's kind of like why I say just put it out in front, right? Does that make sense? And if it's your leading coefficient here, it's like we could have factored it out, sort of.
So my question was, at the beginning, it says it's a quadratic. And I guess it turned out to be a quadratic anyways, because you got x squared. But couldn't you start out by putting an x squared somewhere? Or you should factor it out anyways.
If we're gonna do it in factored form, right here in factored form, we don't have our square, right? This is actually my solution that I should put for this problem, right? They asked for my quadratic in complete factored form, right?
Oh,
This is the complete factored form of the quadratic. If you put it here, like we don't just see an x squared here, we see an x and we see an x. So if you're asking, like, there is something you can do. So I think this is a good question. If the thing that they say is a quadratic, the first thing you can do is you can put your 2 sets of parentheses down. You know it's got 2 factors because it's a quadratic. Now they might be the same thing, right? We might get a multiplicity or something, but we know there's 2 of them. So as soon as they say quadratic, I know it's got 2 factors. You can put your little sets of parentheses down. Any other questions? So I know I wrote this out, but this isn't what they were asking for. This was just to sort of like verify that, like, the thing that was saying up here, these were my zeros, right? If I want to solve for my zeros, I'm going to get x equals a -3. I'm going to get x equals 2. Is the same thing as saying when I plug in a -3, it's giving me 0. So they give you your zeros here in a really sort of weird way. And so if that's the thing that's tripping you up, I don't think we did anything like that in the not homework, notes, right? that is something that's completely different, might be worth noting. They can give you the zeros in a few different ways, right? The other thing this tells me, if I want to think about it graphically, is it's going through the point minus, or it's going through the point 20, right? That's also how we would find it on our graph, is it's going through the intercept. So that might have been a better way to get at it, maybe even. Questions about that one before we go on to these other two?
What if it's asking for, so this one is asking for a quadratic, okay, it has two sets of factors.
Mm-hmm.
What if it's something bigger, like, I
Then
don't
they
know what
got-
the other ones are called. What's
they
the
got
cubed one called?
A cubic is just
Oh, a cubic.
Cubic or
So-
quartic is the next biggest one. They would have to give you more factors, or they would have to give you more multiplicities, right? They would have to add up to whatever the heck they're telling you over here. So that's a good thing to note. Your factors should absolutely add up to whatever the degree of your polynomial is.
Okay, but this one gave us, it's a quadratic, leading
it gave-
coefficient is 7.
And it gave us 2. So
The two, those are the two x-intercepts, right? -3 and 2?
Yep, that's another way to think about it.
Okay, but it doesn't have to give us a multiplicity necessarily.
No.
Okay.
But we know since there's 2 of them, they both got to be multiplicity of 1 to add up to 2.
Okay,
They start giving us more zeros than what we got in degrees of the polynomial, then they're doing something wrong.
okay.
Yeah, they definitely got to add up to each other. Your zeros and the degree of your polynomial should be one and the same, right? Just like your zeros and your factors, you're getting your factors from your zeros. And so when you multiply your factors through, they should give you the degree of your polynomial. So the graph of the polynomial f of x with leading coefficient plus or minus 1, so they're being really nice and not making us solve things there. And introduce zeros is shown in the figure right in complete factored form. Ooh, gonna have to squint on that one. What is that, going by 2s?
Yep.
Yeah.
Okay, so I think maybe just getting the zeros off the graph is probably like your first step, huh? So what are my zeros?
-4
Mhm.
and 2 and 8 is what I got.
Yep, so these are my zeros. Now I want to write the factors from my zeros. So I'm doing f of x. I'll ask you about the leading coefficient in a second. So I know I got 3 zeros. I should have 3 factors. Now this is the thing, and there's really one thing you got to kind of remember around this. If I get a -4 as my zero, what does my factor look like?
X plus 4.
Yep,
On this
absolutely. So the main thing you have to do is like remember to flip the sign on these things, right? This is always x minus k, and this is always x equals to k. So there's always a negative sign, like sort of within the formula, right? Is one way you can think about it. But if we're solving x equals a -4, right? This is the other way. If we solve this thing is previously how we would do this. X equals 4, right? The solution would always be kind of the opposite of whatever the heck this thing was. If we got a minus here, this would be plus. If we got a plus here, this would be minus, right? So now we're just going the other way. We're going from here to there. So if it's a -4, this one's going to be +4, right? So that is like probably one of the bigger things in the section. Probably the big thing is like, well, this is minus, this is plus, and if this is plus, guess what this has to be? All I want. Minus, sorry, probably said it pretty quick. And the last one, I'll let y'all do this one. X
-8.
Ooh, yeah, that's it. Now there's one other sort of thing we should do. We should write what the leading coefficient is on this thing. Is it a positive or negative one is the question. And how do you know?
Wouldn't we have to factor this out?
No,
Or,
it is factored out.
oh yeah, I'm sorry. I mean, multiply it. I mean,
No, distribute, no.
distribute.
There's like not a lot of work. You
Oh,
really-
hey, wait a minute. I know. So it's following a line that's
Yeah.
going from left to right. It's going up. Therefore, it has to be positive.
That's exactly what you do.
Okay.
All right. So anybody else that didn't catch that, what you're doing for this leading coefficient is the same thing we've been doing for leading coefficient. And so you're looking at the end behavior of this thing, right? And so we look at this, and it looks like an odd graph because it looks like a line that's going up from left to right. If we look at the end behavior, it's going down this way, it's going up that way. So remembering end behavior, it either looks like, quick recap of end behavior, it's either going up or going down, right? We're thinking of a line if it's odd, we're thinking of a parabola if it's even. Positive or negative, right? And so they're asking, is it positive or negative? It looks more like a line. It looks like a positive line. Okay. And so if you can do this, I think you're going to get a good portion of this section correct, probably. The other thing I think is multiplicities, but we don't even get that to there until the later problems. So this one, they want to know, did I answer the question? Let me double check. Graph of the polynomial. Yeah, write in complete factored form. That's it. I feel my coffee kicking in, I think. 17. What is the first thing I should do here? What would you do if you saw a graph and it asked you to write the factored form?
Zeros.
I would get your zeros off of there. Get your intercepts, get your zeros. What are my x values for those zeros? So I'm looking here, squinting my little eyeballs. This is what's 2, 4, 6. A minus. How many zeros does this thing have? You should be giving me 4 numbers, right? I believe these are the 4 numbers we're getting off of this graph. So if you can give me the zeros, then the next thing is, can you give me the factors? So 1, 2, 3, 4. Okay, what's my first factor here?
Plus 8.
X plus 8. The next one is x
Plus 4.
plus 4x
Plus 2.
plus 2 and x
Minus 4.
minus 4. These are my 4 factors. There is one sort of other thing I've got to account for, and that is that leading coefficient that they tell me about. What is my leading coefficient here?
-1.
It is -1. Why are we saying it's -1? Because this is an even function, so we're thinking parabola. Does this look like a upside down parabola or a right side up parabola? And you told me it looks like a negative or upside down parabola. Is that what I'm hearing?
Yep.
All right. Sounds like we're on the right track. Oh man, did we tell you that like the stuff that we learned in this course is going to come up again and again? That end behavior, right? All the stuff.
Sometimes.
Factoring. Ooh. questions about this one? How we're getting the zeros? How we're getting the factors? So I think maybe the hard thing is like remembering what order to do these things in. Maybe I don't know. It's like, what do I need to do? I need to pick off the zeros. I need to find the factors from the zeros. And then maybe the thing that you might forget is that leading coefficient. Don't forget that guy. Go back, read your problem, make sure you answered the problem, right? If you do that, you might be reminded that you need that leading coefficient. Critical thinking. The graph of a polynomial f of x with integer zeros is shown in the figure, right? The complete factored form. Now the leading coefficient is not a plus or minus 1. Okay. So we see a graph. My approach is still the same. The leading coefficient isn't plus or minus 1. But we do know whether it is positive or negative. So this should it have a positive or negative leading coefficient? It's not going to be 1, it's going to be some other number, but it will still be positive or negative, right?
Positive?
It will be positive because this looks like a line going up, right? It's a positive odd function. So it should also be getting an odd degree function, right? So what are my zeros? So pick out your zeros from this thing. I think the first one is over here at what, -1. The next thing is at 1 and 2. Try to find another point on this thing. It's so hard to see. That's not really a good point. I'm going to end up having to draw another point, I think. So what does my function look like? I can write up the factors. And I hope I'm not going to spend a whole lot more time. But you're going to flip the sign to write up the factor, right? And here they say leading coefficient isn't plus or minus 1. So what should I put in front of all these things to solve for my leading coefficient? What do we usually use for leading coefficient? A. Yeah, put my big A in there. All right, so I have these things, and I want to solve for A. I need to plug in something for my X, and I need to plug in something for my Y so that those things disappear, right? I can solve for my A. What do I want to plug in to get rid of them? Without getting rid of my A. So if you plug in one of your zeros, it's not going to work very well. I don't know if you noticed that, but if we plug in what, -1, 0, -1, 0 is going to give me 0. It's going to give me A times 0. It's not going to solve for A. So if you did that, it's a good way to think, but it's not going to get you there, right? So what I want to do is I want to pick a point. I want to find a point on this graph somewhere. It doesn't look like it really goes through evenly anywhere besides where, like 0. Those things in your brain, right? Those are my x-intercepts. This is my y-intercept happening at 1 is going to be 0, 1. With that said, what value do I want to plug in for my f of x to find my a?
1.
I want to plug in 1. What value do I want to plug in for x?
0.
0. So I do 0 plus 1, I do 0 minus 1, and I have to plug in 0 3 different times here. And I think that's the only point that it goes through evenly, right? I think everywhere else, if there was another point it went through evenly, we could probably pick it. You're not narrowed down just to one point, but you do want to make sure it goes through evenly. And that looks like the only one that's going to go through evenly. This should clean up pretty quick. I've got like 1, I got a minus 1, and I got a minus 2. I got to multiply here, right? And so what is my A? My A is what value?
1/2.
Yeah, so my A is a half. And so have I done, I did a lot of work, but have I done what the question asked me for yet? What are they asking me for? I think they're asking for complete factored form of this thing. So what do I have to do now? I'm almost there. There's one little thing.
Plug in the 1/2.
Plug in the 1/2 back into this thing. That's it. I'm doing f of x. I'm plugging in my 1/2 into this thing, and I got my 3 factors. So my 3 factors were what? X plus x minus 1 and x minus 2. All right. Questions? All right, I'll watch for you. Okay. Questions about this, about how we did this one? So this one does require a little bit more work, a little bit of solving for it. We start by finding the zeros of our function. From our zeros, we can find, let's move down a little bit. We can find a factored form without the leading coefficient, right? If we know the factored form without the leading coefficient, the strategy to get this leading coefficient is to plug in another point that is not a 0. So we plug in another point that is not a 0. We plug in our y-intercept. It makes it really nice because there's a 0 in our x spot. And there's a 1 in our y spot. Makes it a little bit easier to solve than probably any other point because they're plugging in 1s and 0s. But we solve for A, and then the last sort of thing to do is to go plug this back into our formula. Now we have a formula for this function. Okay. So now we're starting to get into things with higher multiplicities. So write a polynomial f of x in completely factored form that satisfies the conditions. Let the leading coefficient be 1. So 43, 44, 45. I think y'all can probably do that on your own. They're giving you zeros, they're giving you multiplicities, and they're giving you a 0 and a multiplicity. So I want you to go ahead and I think you should be able to do these things. I don't know. We hadn't really talked about multiplicities, but multiplicities, and I've kind of danced around it. It should be the exponent on your factor. It should be the exponent on your factor, right? It's like we have that 0 multiple times. We have that factor multiple times. Okay, if there is a 0 at -1, what does my factor look like?
X plus 1.
X plus 1 is my factor. And if there is a 0 at 6, what does my factor look like?
X minus 6.
X minus 6. So these are the two zeros they give me. Now I want to do multiplicities. So at the -1, there was a multiplicity of 2. What do I do with that information?
Put a 2 behind above it.
Put a 2 on. I didn't really hear the rest of that.
Above it.
On the exponent, right, of this factor. So there are 2 x plus 1s here is what this is saying. So if I go back and solve this, I'm going to get x equals -1. I'm going to get x equals -1 twice, right? So we did the solving for the zeros. Now we're kind of going the other way from the zeros and going back to the factor. So we have to be able to solve for this thing twice. We have to be able to solve for this thing once. So one thing I'm probably not going to do is I'm probably not ever going to write that thing there. If it's got a multiplicity of 1, I'm probably just going to write it without the 1 in the exponent. The 1 in the exponent doesn't do anything, right? That's it, though. Any questions?
It has degree 3. I guess if you distribute, you would end up with a cubed x.
Oh, that's a good thing. So we're doing 2 plus 1, right? If we multiply this thing together, it's going to give us a square. Then we're going to multiply that leading square term by another x. It's going to give us a cube.
Which will give us the cubed. Okay. Yeah, because that's what I'm trying. Because I started looking at it going, okay, I know this is going to have an x cubed in it, but I guess I wasn't doing it in the right order or something.
Yeah, we can
Confusing
count.
myself.
So if you count the exponents, that's one way you can do it. 2 plus 1 will give you 3. If we expanded this out, that might also be another hint. X plus 1, right? X minus 6. We can just look at the first thing being multiplied. X times x is going to give us x squared. Times another x is going to give us an x cube.
Mhm.
That will be the largest power of x that you have in that thing. So they give us zeros, they give us multiplicities, they're giving us it verbally now. I think the next thing that they're going to do is give it to us graphically. But either way, you should be able to pick out your zeros. You should be able to put your factors from your zeros. You should be able to put the multiplicities on your zeros. 44 says we got a degree 4. I got zeros of 5 and 7, both with the multiplicity of 2. So if I got a 0 of 5, what does my factor look like?
X minus 5.
Yes, x minus 5 is my factor. And the other one says I have a 0 of 7. It look like this. And it says they both have a multiplicity of 2. So what do I need to do?
Square both of them.
Square both of these. So square. And does that add up to what they're saying? It says something that like this is a degree 4 polynomial. Does that add up to 4 degrees?
Mhm.
Absolutely. The next thing is 45. I want to do 45 says degree 4, 0 is 2 with multiplicity 3, and 6 with multiplicity 1. Whew. So probably distinguishing your zeros from multiplicities might be one thing you messed up on, right? So don't flip those. The 0 is 2. So if the 0 is 2, my factor looks like
X minus 2.
x minus 2, and then another 0 is 6. So that factor looks like what? X minus 6. It says the 0 of 2 with multiplicity 3. So what do I have to do with the x minus 2?
Cube it.
Cube it. Put a factor of 3. Do I need to do anything with this thing over here? If you want to put a 1, you could put a 1. Does that give me the degree 4 that they were talking about?
Yes.
Yes, 3 plus 1, right? Will give me back degree 4.
What about the leading coefficient? Do
The
we just
leading
suppose
co-
that it's 1?
Yeah, they said suppose it's 1 here, or didn't they?
Oh,
I think so. I think that's what those instructions are saying. Let me double check.
Yeah.
oh, okay, okay, yeah, I missed that. Okay.
Yeah, let the leading coefficient be 1. So yeah, good question. They covered it. Yeah.
Let's say that they didn't suppose it was 1. How, I mean,
They would have to give it to you because I don't know if there's any way to solve it. They might be. Yeah, they might do. I mean, they technically could do some kind of weird stuff, right? Where they're like, here's another point or something. I don't think they ever do that. They
Okay.
don't ever do that in this book.
Yeah, cuz this going back in so many different ways to do the same thing, it's kind of confusing me. Because there's no linear one way to do it. It sort of goes back and forth how they ask you the question. So just making sure I can cover everything here.
I think they're giving you the same information, but they're giving it to you like either graphically, right?
Right.
They're giving it to you verbally. And so basically that's the two kind of approaches they take. This one, right, is a little bit different and it makes you do a little bit of extra work.
Right. But in this case, we have the y-intercept to work with.
Yes. And so we had another point to work with. So you have to get
Okay.
another point if you want to solve for a leading coefficient that's not 1 or -1. So
Okay.
we don't like that's this is a little bit extra work and it's not really related to all the other stuff we're doing so much, right? The zeros and picking out your zeros and all this stuff and understanding this stuff conceptually. So a lot of times what they like to do is just say, assume it's 1 or -1, right? They don't necessarily want to focus on this every single time, if that makes sense. It's something you should know, but it's not something that's necessarily the predominant focus of this section, right? If you're getting the zeros, if you're getting the factors, that's the thing. That's the larger part of this section. The graph of either cubic, quartic, or quintic polynomial with integer zeros is shown. Write the complete factored form. So we talked about this. Reminder of what, like a square root function. The basic square root function has a 0 at 0 as it goes through the origin. So this is what a multiplicity of 2 might look like, right? One way you can think about it. Sort of a little squiggly thing. And so if we think about y equals x cubed, it has a 0 at 0, and it's got 3 of those zeros at 0. I think in the notes I tried to shift this left or right so we didn't have so many zeros in it. But this is basically what I was trying to get at, right? If it looks like a square root or something, it's got at least 2 zeros in there. It's like arriving at the party, see someone it doesn't like, and turns right around, right? All right, so if it looks something like that, then you might have to account for the fact that it might have more zeros than 1. So we still want to pick out the zeros. The other thing we want to consider here are the multiplicities. Okay. I want my 2 zeros. Everyone's talking about multiplicities. What's that? -2, I think is the first zero. And then 4 is my other 0. So reading from the graph, I hope you can pick out the number x equals -2 and x equals 4 off the x-intercept. Hopefully we give you a good enough graph to read. And now I want to think about multiplicity. So what would be the multiplicity of that 0 at -2?
2.
There would be 2 of them there. That looks like that sort of quadratic vertex. It's hitting the axis and turning around. So anytime it hits it and turn around, it's got a multiplicity. And it should really say at least, right? It could be more. It could be 2, 4, 6, 8. I think in the problem, they're narrowing it down so they say cubic, quintic, quartic. So Here, this probably actually isn't an issue just because of the way that they worded the problem. And they probably escaped that sort of thing, right? And then the 4, how many times is that 4 happening?
It's only one time.
And so if it goes straight through, it's not doing any sort of squiggle thing about that axis. It's just once. They said, right, the complete factor form of f of x was our instructions. And they said, hint in exercise 51 and 52, the leading coefficient is not plus or minus 1. So
Right.
that will come up again. Here
So
we
here,
it sounds like we can assume it's plus or minus 1, and that's what I'm going to do, whether they wanted us to or not, because that's the way they worded it. But I want to write out my factors. So I want to write out my factors first, and then I'll consider my leading coefficient after that. So my first 0 is a -2. What does my factor look like?
X plus 2.
X plus 2. And what power should that be to?
Two.
To the second power. And then I have another factor that looks like
-4.
-4. And do I need to put, what do I need to put up here?
A 1.
A 1. Yeah, I don't need to put it though. So that's it. There should be a 1 up there. If you want to put it, you can. Questions about this one? How we're getting these zeros, how we're getting the multiplicities, how we're writing the factors. And then the other thing I said and didn't do, I want the leading coefficient. So is the leading coefficient here plus or minus 1 is the question.
+1.
It's going to be +1 because this thing looks like a line, right? It's going down to the left. It's going up to the right. My end behavior looks like a positive line. So you might also notice it's an odd function. 2 + 1 is going to give you 3. That matches up with the graph. So making sure your degrees match up with what the graph looks like is also a good thing. If you're getting like 4th degree function, right, and your graph looks something like this, you know something's off because it should be odd, right? Your parity is not matching up. That's the big fancy word to say if something is odd or even, parity. Okay. 49. What are we doing with 49? What are my zeros? What are my multiplicities? Looks like we're going by 1, 2, -3 looks like one of my zeros, and then +3 looks like my other 0. What's my multiplicity on that -3?
2.
It looks like a vertex in the axis and turning back around. 3, what is my multiplicity on +3?
Also 2.
Also 2. So now we're looking at this thing. My f of x has 2 factors. I don't know why I wrote it way over there. I have 2 factors. One looks like x.
+3.
Oh man. I guess you get this one right by default, even if you don't know how to go from 0 to factor, right? One of that first one should look like x +3. The next one should look like x -3. And what else should I put on these things? Both of them should have
Exponents of 2.
I think I heard it right. Exponents of 2. And what about the sign out in front? What am I going to put for my leading coefficient on this thing?
-1.
It's got to be -1 on this thing, right? And why is it got to be -1? Because if it look at this thing, It is an even function, so it looks like a flipped up parabola, right? Overall, this is what, 4 degrees? So it is an even function, both symbolically and graphically, right? We can check those things. Questions about this guy? Okay. Was it 49.51? And this one they told us, oh man, this one is going to be one that is not plus or minus 1 in the leading coefficient. So this one we got to do a little bit of extra work on. But I'm going to do my zeros. I'm going to find the multiplicity of them. Still the same approach, and then we will worry about that leading coefficient after the fact. So what is my 0? It looks like one of them is going through at -1 over there. It looks like one of them is going through at 1. My 0 out of -1, what is the multiplicity on that thing?
2.
2, and then what would the multiplicity on this thing be?
One.
Careful.
3.
3. So this is the cubic looking thing. It almost levels out when it goes through the axis. It looks like it levels out. It really doesn't. But it kind of looks like it, right? It looks like it almost goes flat. If we zoom in and zoom in, we'll see it actually doesn't. But it, like from a distance, it looks like it flattens out like along the axis, right? It gets really narrow in there. And so this is a thing, stare at it for a minute if you have to, right? This is a thing that you really need to get down from the section. Like if it hits it and turns around, that is multiplicity of 2. If it goes straight through, that's just 1. But if it does a little wiggle thing, like right through the axis and flattens out almost, that is a multiplicity of 3. Now we write this thing out. Equal. I got my 2 factors. +1 and then that's -1. And this one, you do kind of got to know how all this goes a little bit, huh? What should be on this x plus 1 should be a exponent of
2.
2. And then that you should make this one an exponent of 3.
3. I just write my factors first and then I just go back and check what the exponent should be. I think it's a little bit more efficient, but,
It's fine, yeah. However you're getting it. Okay, and then they tell us that we don't know what this thing is. So we do have to still solve for A. So this is one of those ones we're gonna have to go back and solve for A. Overall, this is 51. Should A be positive or negative when we solve for it?
positive.
It should be positive. So we can do sort of
Yeah.
checks and we can kind of check on like what it should be a little bit. We want to look for a point where it goes through evenly. I think there's one other point on this graph where it goes through evenly.
Miss Lisa, can you check the chat?
No,
Okay.
Can you
And so-
check your email?
no.
So you're withdrawing me for no reason, just because I told you you should have told me that I had class on Fridays?
Okay.
I can
We gotta
report
do.
you.
We gotta
You're
do.
literally gonna
classwork.
withdraw me for no reason.
We've got to do classwork right now. I can't have a conversation like this.
She
No.
doesn't want to email me back. I literally just told her that she should have told me I had class on Fridays because I was
This
missing
isn't a
every Friday.
conversation for
And now
class.
she's
If you want
not.
to
She's
stick
saying,
around
okay,
and
well,
have
I'm
this
gonna
after
withdraw you.
class,
Good luck.
we can have this conversation after class if you want, but I can't have it right now. in
You
the
think
middle.
that's right?
I'm not having this conversation. If you want to have it after class, we can have it after class, but right now we're in the middle of class. Okay, so we have this equation. We're getting our two factors. We have a leading coefficient here. And so to figure out our leading coefficient, as I was saying, we need. So we should be getting the point 0 minus 2 for our other number. Okay. I'm looking at 0 minus 2. So if I'm looking at the point 0 minus 2, what am I plugging into my f of x value?
-2.
Yep, plugging into minus 2 to my f of x. Anything I want to solve, what am I plugging into my x values?
0.
I'm plugging in 0. I'm doing 0 plus 1. This one's going to be squared. I'm doing 0 minus 1. This one's going to be cubed. So there might be an issue of do I have a positive or negative here, right? I think it's probably the question that you have. Having 1 squared, having minus 1 to the cube. Okay, so I do a 1 squared, I do a minus 1 to the cube. Overall, what is the sign on this side going to be is what I'm asking. So how would you solve that? Like, how would you? I mean, there's a few different ways, but like, what might you do? I would say I have what, 3 negatives? Is that where we're going with this? And if I have 3 negatives overall, is this going to be positive or negative?
Negative.
It will be negative.
Negative. My bad.
I think I said it earlier, right? But my A should be positive 2. If we got a negative 2, you might notice your leading coefficient doesn't match up with the graph. So it should definitely be positive 2. We have a factored form. We have the leading coefficient 2. We're plugging this thing back into our original function to solve for the polynomial. Just plugging that 2 back into the thing we had previously.
So, Mr. Silvers, we solved for the A for this one, but what showed us that we needed to do that since we didn't do that for the previous two?
So we solved for it on this one. We didn't do it on the previous 2. And we didn't do it on the previous 2 because they kind of hinted at that it should be plus or minus 1. Is that what you're asking? I kind of heard half that question and it kind of faded a little bit.
Yeah, like what indicated that we needed to solve for the A on
Basically, because they told us the leading coefficient is not plus or minus 1 on 51. They literally, like, it's literally because they told us, you know. If they don't tell you, you really don't know. Like, and if you don't know, you should technically go and try to solve for it. But here they kind of told us these two would be plus or minus 1 by saying that this one wasn't. It's like power of deduction says if that one's not, then the first 2 probably are.
Yeah, so when they
Yeah.
give us problems like this, they're always going to tell us whether it's not or it is.
It should lead some sort of indication, and if it doesn't leave any sort of indication, you really should probably try to solve for A and make sure it is. Because if we try to back solve and do the same thing here, right? I could pick another point here. I could try to solve for A on these things and pick another point, and my A should end up being like a minus 1 when I go and solve for it. So that would be another indicator that your leading coefficient's plus or minus 1. I just don't want to do all that extra work on these 2, right, to solve for my A. And so I'm going to use their assumption that it's plus or minus 1 to save me a little bit of time with my work.
Okay.
And in general, like that's sort of what I think for the most part, if it is plus or minus 1, they will definitely tell you, right? They'll just say, assume it's plus or minus 1. That will be like a really common sort of approach that we probably take to these problems. To be honest, I don't remember what's on your test or quiz or anything. Whether we do that or not with the leading coefficient.
I don't think there was a when that wasn't plus or minus one on the test, or
Yeah, I think on the test I might have just did the plus or minus one, but
yeah.
I don't remember it off the top of my head. So it's definitely something you should know is like if it's not a plus or minus one, I have to go plug in another point. And it's an extra little thing you have to do. With that said, like I think I don't know.
That makes sense.
Yeah. For the most part, I think they try to keep things simple. Let's see if they do it here or not. State the minimum degree for this. They may not even ask you for the leading degree, right? Or the leading term. Leading coefficient, that's what I was looking for. It may not even ask you for that. So the graph of polynomial is shown here. Estimate the integer zeros and state whether the multiplicities are odd or even. State the minimum degree of f of x. So here it sounds like they're even like just dancing around that. I think I went out of order a little bit, didn't I? Yeah, I went a little bit out of order. So I went 45 and then I skipped to 47. Now we're going back to 41, 42. So estimate the integer zeros.
Are these just like extra? Because I don't have these on my homework sheet.
Yeah, they're not on that. I put them up like earlier this morning.
Okay.
They're part of the written, or they're part of the book assignment. They should have been in there, but
Okay.
they're good practice for what we're doing. So we'll go over these two. The graph of the polynomial is shown in the figure. Estimate the integer zeros and state whether their multiplicities are odd or even. State the minimum degree of f of x. So we want to find the zeros. We want to find the multiplicities. So 0 and multiplicity. And so staring at this graph, it looks like we're going by ones. It looks like this one is at a -1, 2. It looks like this one is at 1, 2, 3, 4. And then I want to talk about their multiplicities. And I think I'm going to see plus or minus right out the polynomial itself because we're right there. We might as well. I feel like these are more complicated than those previous graphs, to be honest. They're just like they try to make it simpler by not making you write the polynomial. But what would my multiplicity at -2 be? How many times is this thing going to occur over here? What does this look like?
A cube.
That looks like a cube. What about this thing at 4? Let me finish it. Should be 2, right? Okay. Okay. So that thing looks like a cube. That thing looks like it's happening twice. What do they say? Estimate the zeros and the multiplicities. Should this be an odd or even function? What does it look like overall? It looks like a
Odd.
It looks like an odd. And is that positive or negative leading coefficient?
Positive.
It should be positive because this looks like a line going up. So now we're doing this. You've already told me it should be a positive one leading coefficient. I should have 2 factors. One of them looks like x.
+2.
+2, and this is to the 3rd power, and this one looks like x.
-4 to the 2nd power.
Exactly. Thank you. Questions about this guy? How we're getting the zeros, how we're getting the multiplicities. Can you pick off the zeros off the graph? I hope so. Can you do the multiplicities if it looks like a cube? Do you know what that cubic shape looks like? Do you know what the vertex looks like? Do you remember your end behavior? Does it look like a line? Does it look like a parabola? Does it look like it's going up? Does it look like it's going down? Looks like a line going up. It looks like odd. We got 3 plus 2 is going to give me what? 5. So this is a minimum degree 5 function, is what that's saying. Questions before we get to the next one, last one? I see 3 zeros here that I got to talk about. 1, 2, 3. 3. My zero, my multiplicity. It looks like my first zero is what, -7. Ooh, 2, no. 2, 4, 6, -8. Sorry, we're going by twos. The next one is at -4. The next one is at 2. Now I've got to think about multiplicities on this guy. That -8 is happening how many times? 2 times. That -4 is going to happen
3.
3, that's it. And then the 2 is going to happen.
3.
It's the same thing. It's still squiggly. Is this a squiggly going down, right? So whether it's a squiggly going up or squiggly going down, whether it's a vertex that comes like up and hits it, or whether it's a vertex, do we have one? There we go. A vertex that comes down and hits it, right? We're still just looking for that. Either it's a vertex shape or it's a cubic shape, right? It could be going up, it could be going down. So I guess we have examples of all those. Now I'm gonna write out my factors. Factors here. My first factor is
X plus
8, and that should be to the
squared.
square. I got an x plus 4, and this should be to the
Okay.
cube. And then last thing, I got an x. This one
Minus.
should be -2, and this one should be to the cube. Now, if you got this, you got a good portion of it. You got the big, ugly, nasty part. Don't forget your leading coefficient. What should my leading coefficient be here? And we're assuming it's plus or -1. It's probably not.
-1.
Should be -1 because this looks like an inverted parabola is the thing you're thinking about, hopefully. Questions about this? About how to get your zeros? About how to get your factors? All right, we're like right at time for class. I think I'm gonna hit the probably hit the record.